初勝利活用上の和則星新次野崎高橋佐藤ロスクマカベユキ。
Thank you for the introduction. I'm Atsushi Okori of Tohoku University. So I'm talking about this is an experience report conducted by Tohoku University, jointly Tohoku University and NEC Solution Innovator. Let me begin with impression that the following. With SML Sharp, we can produce robust system with legal specifications and high-quality flexible code in a highly productive manner, thanks to the SML Sharp feature, which include static typing ensuring compile time verification of behavior, high-level declarative programming, component programming through flexible function, although current SML Sharp has some weakness in performance. And when I said this, I fully expect some reaction that boring cliché on functional programming, or we have been saying this for years, maybe years and years, yes, I know, but there is one big difference of those I am saying, and also you are saying. That is that these are not my writing, but a translation of an internal document made by a company, which says, confidential, but I'm granted to show you a few pages, and page 4 exactly say this. This is prepared by people who never experienced with functional programming, nor any motivation of promoting functional programming. So I would say this has some serious truth in it, and I'm talking about a project culminating this kind of impression by the company. So the project overview. Well, this kind of project can't start instantly. So there are some preparation, and after some effort of persuading the NEC group, I have miraculous opportunity to get in touch with the person who is in charge of entire software in the entire NEC group. Entire NEC group, not of one company. And so I try to persuade him the potential of functional programming, SML Sharp in particular, on innovating Japanese software industry. Well, it's a big we need to aim high, and then we come to share the motivation and general goal of revitalizing Japanese manufacturing industry through software innovation using high-level language, including SML Sharp. Well, I'm of course serious, and these are very general motivation. And now making the first step, Tohoku University and NEC Software Tohoku at the time now, NEC Solution Innovator is the current company name. Started collaboration on enhancing software productivity through SML Sharp. And to probe the potential, we conducted a pilot project of developing a practical software system using SML Sharp. That is what I'm talking about. The target system is an ERP system managing the company's software project. And project size is 5 people from NEC and 2 Tohoku University. This 2 is the total number of SML Sharp team, unfortunately very small. And investment we spent 15 months and about 50 months cost. And funding. This is solely on NEC Solution Innovator's internal budget. So no JSP. JSP is kind of an NFS in Japan, and JST is a funding agency like DARPA, nothing to do with military, by the way. And next is the military controlling everything about funding of the university. But no funding involved yet. That means that this project is done by seriously armed companies' precious budget, so that therefore they evaluate very severely and also very seriously. So that is a project overview, and I begin with contacting with NEC group, explaining functional programming and SML Sharp in particular. So I need to put the background shared with you. That is a feature of SML Sharp. This is my writing, so maybe you can take as an advertisement, but this advertisement is well taken by NEC group, and so there we have a joint project. Now, SML Sharp is an ML, so that we inherit all benefit of an ML programming. In addition, SML Sharp provides some important practical feature. And some of them, we only show some of them. One is record polymorphism. As I show you, this turned out to be a rather strong tool for modular programming in data-intensive application where you have lots of field I will show you later. And second one is direct C interface through native data representation. In SML#, almost everything is native, including integer floating point numbers are of course native, and also heap object, which are also native in the sense that it's compatible with C layout of a struct. And the third one also play an important role in seamless SQL integration. SQL commands, which are inherently polymorphic, are themselves are ordinary polymorphic expression in SML#. That means that every piece of SQL are completely type checked. So therefore, of course, SQL injection was such kind of thing is not even an issue in SML#. And also, any tool that is based on type-based analysis goes through, of course, for SQL. And fully concurrent non-moving GC. So this, with C interface and this non-moving fully concurrent GC, we can just have a merge threading on merge core by simply calling thread creating library. So this is about SML#. Now we go back to the development of this project. So this is the development detail. Development step, of course, we have a target system selection, starting with target system selection. And then two stages of development. First, develop prototype, and then the second one is rewriting various parts to come up with version 1 system development. And then evaluation. And now currently being used in 5 division, and planned to be used in the entire branch of this Tohoku branch. And collaboration, we have been collaborating very tightly throughout this 15-month period. We have joint weekly meeting almost every week to analyze the requirement, to discuss the program, and to review the design and code. We actually do code reviewing and code rewriting together. This helps tremendously to improve and very quickly develop functional programming skill among engineers in the company. Most of the code is written by an AC, and we, Tohoku University, do education and SML# extension, necessary extension, and basic library development. And the programming environment is that we make a combination of various components. I will show you later, but basically Linux system and SML# separate compiler and make system with system linker to get everything together. This is a detail of the thing, and I'm not going to the detail of interpretation of this, the lack of the time. And so now we go through from the beginning to the evaluation in this order. So of course we start with target system selection. We selected the selected target is an ERP system having the following feature. First is to report the status of project based on the current database state. Database is being updated very frequently, so that this is quite important. And ordinary ERP system doesn't provide this kind of feature. So it's kind of real time showing the current state, and also simulates the future cost and expected profit of project. And the rationale of this choice are the following. First of all, such a system is itself highly desired one in the company. And second, it represents a typical business application involving database access, computation based on business logic, and also report generation. And also the development must contain an entire software development process, because we don't have much experience in this field. So we have started with analysis, problem analysis, and requirement identification, and so on. And the final point is that this product is used and evaluated by the company. Now, I wanted to make 2 points about the target selection. This target selection is of course done by company, and it is not tailored for in any sense for SML#. On the other hand, SML# turned out to be quite suitable for this kind of target. I would say it should be, because SML# is designed for ordinary software development, including database, seamless database access, and so on, with detailed data. So system is running and being used currently in the company. So this is a Japanese simulation window, by the way. So now let me summarize the experience. So we have various lessons learned and new finding and overhead. Observe some interesting technical language issue. And so lesson learned is that we have encountered various problems in deploying ML as a production language in the company. And also development with best of breed components is essential to build something in a cost efficient way. And we have found new finding of some kind of software pattern for web application, this kind of business web application. And also we find some useful record polymorphic pattern and observe some language issue. Various technical issue, interesting issue comes up during this project. So I will, in the rest of the talk, we will try to briefly report on these lines in the blue. Yes, so first is a miscellaneous issue. So this is an ML project, but of course ML project is not just cool ML coding. In order to deploy ML in a company, various things comes up. First is programming education, but this part is rather easy. We are accustomed to educate ML to various people, but so in this case, this stage is we have an intensive course on functional programming and SML for target for engineer. But this is not this is just one piece. There are many other problems. For example, software quality control. This is the company's project, serious project, using company's money. So the product must accompany, satisfy the quality standard of the company. So that means that that should be verified by various documents. So various documents must be prepared, of course. But we had find much standard for functional programming. So we had adapted the existing standard in the company and to try to adjust during the project. And the design method. So we need to design from the scratch, rather not too huge, but well, certain size of the system, on which we found very little resource on ML-based architecture design, for example, design pattern. So as a compromising starting point, we adopted the MVC approach and have refined their component for ML-based system. During this refinement, we find rather interesting design pattern we call abstract model construction. I will try to explain later. And acquiring domain knowledge. And in order to work this collaboration works, university part must also familiarize to the problem, in this case accounting, so that we learn management accounting and the company's accounting principles and resources. So now the best of the breed component, I believe is said, is that in a large system like this, it is essential. So in the initial system design, we put the various possibilities on the table and try to select the combination which works in a cost-efficient way. In this respect, SML Direct C interface has greatly contributed to this practice. As far as any library has C API, then they can be effortlessly used by the programmer. This is just a first CGI example, some part of it. But in this way, so you don't need any language level support, but user level support. So the C interface is, we find it essential. Now that we corrected various components and then try to design a system. As I said, it is very much true. So we started with ordinary MVC architecture. Now this is the final shape we come up with, so that the model that is realizing the service. So we organized. Finally, we come up with the organization of a two-level layer. One is raw model, we call it. This is large relational database on SQL Server. and abstract model, which is our meaning, our naming, which is realizing required service. This two-layered organization is interesting finding. I will elaborate later. And controller and view part, it works fine with the traditional notion with some supporting library. This is kind of our architecture design. So let me try to convey the abstract model construction. Why it's necessary. Now, MVC pattern works fine for a simple web application like where database corresponds to a set of objects, and model is a database object access directly from database. This kind of thing works for very simple web application. However, in a real business application, we typically have a relational database containing a set of large number of highly normalized tables. Normalized means that various set of integrity constraints. In order to satisfy various integrity constraints, columns are no longer just a value, but a kind of code to be interpreted by SQL. There is no other way. So it's not just a simple model, but this is kind of encoded data. So in your project, for example, the database consists of 15 tables. Each has 4 to 100 columns, and total column is 395. This is not particularly large, I would say. So abstract model construction is so in order to deal with this, we come up with the following. We observe that database is a set of data fragments encoded as a relation. You can't interpret by SQL. You need SQL to interpret. An object is a set of records reconstructed by SQL query. So we can declare the model in an ordinary sense of model as a composition of a higher order function of the SQL query. This composition can be interleaved arbitrarily. So this is essential and functional programming. So SQL is, by the way, a functional expression, and therefore embedded seamless integration of SQL and ML provide a perfect framework for this. So this is what we call abstract model construction. This works fine. And now, so I don't have time to show, but we can freely combine SQL as far as type correct, and type is always infer. Now, I tried to briefly say record polymorphism is particularly useful for data-intensive application like this kind of ERP system. So that the record polymorphism are modular and compositional data generation. So this is just an example to explain this functionality. Suppose we feed a template with a set of fields, say in this example A and B, and each field of course wanted to independently compute it, and then dispatcher is responsible for generating a complete data. You have given this kind of situation. So with record polymorphism, you can independently code for each attribute. For example, field A function, you only need to look at the type. This type exactly says that this function is responsible for A field, and nothing else is touched. Similarly, you can define B, and then this package is designed this way. Initial data is everything empty, represented by none, and check is to check that everything is filled, and then the field function takes function and apply this function and check it. So dispatcher, if one wanted to dispatch A and B, just compose A and B and fill. This came up to set of subset of fields so that you can arbitrarily decompose various components and independently develop and compose. That is the power of record polymorphism. And we find these are find and worked. And now we find various future issues during this project. And one is generalized natural joining. Actually, this is the old story. We had a generalized natural joining in 1989, a language called Machiavelli. But this join is a kind of recursively joining record, a polymorphic operator. This should play much more clean way of composing various partially produced data objects. So this is now soon available. So initial implementation is done. So it's soon available in SML Sharp. And also we find uniform operation on set of field very useful because set of columns are rather huge. For example, 1,000 column is a typical one. So that and some of them some repetition and uniformity and so on. So we wanted to treat labels as a value. Of course, SML Sharp, we had the first class field selector so that we can actually treat label as a value. However, we can't create a new record by giving some dynamically giving label. So I don't have time to explain this piece of code, but so some more flexible treatment may be desired, and also some dynamic view on record and kind of thing should be there. The conclusion again is the conclusion by our industry partner. It says in Japanese, but this we fully agree that we also view that these two say that SML Sharp is practically feasible. We can deploy it to those areas that require high reliability and productivity. And therefore, conclusion is that we decided to continue this project to wider perspective, and our target currently is embedded system. So that's about the time. So that's all I have to say. Yes.
We have 3 minutes for questions.
Right, so it's really refreshing to see other people praising functional languages rather than doing it ourselves. And at the end, you talked about their evaluation. They concluded that it was gave good reliability and productivity, but you didn't say much about the evidence they had for that. So why did they decide it was productive, and why did they decide it was reliable?
Okay, so in order to give evidence, you need to compare something with some legacy way, but that costs very much. So we didn't have that resource yet. Of course, I wanted to do this. And eventually, we may come up with, so the project is continuing, so that we try to provide such kind of evidence, software engineering evidence in the software engineering sense. But that is rather difficult and cost, requires some cost. So that's pretty much future work. But however, I would say that companies' feeling is that this works. That at this moment, I think currently it's good enough for us.
So they didn't quantify at all what the reliability was or what the productivity was.
Yes, productivity is by the the coding. Productivity in design and coding, and reliability. Of course, we can't provide any metrics or something, because that require some more resource and large-scale evaluation, which we wanted to do, but currently we don't have. But I would say that companies' internal reports say that this is rather promising. So at this moment, please buy that statement.
You said at some point that the academic partners had to learn about accounting. I think that's very good. And my question would be, was it interesting?
Yeah, but, I enjoy learning accounting, management accounting with companies, because that is the real thing to solve using SML Sharp, functional program. In that sense, I enjoy learning. But, is that interesting? Technically interesting is a different matter. But I enjoy with a company, and we learn accounting. We actually learn textbook and also the internal structure of company as an instance. That's quite enjoyable experience, because we are going to put in a program. That knowledge is put into a program. So in that sense, it's interesting.
Thank you.
Thank you.